Thank you very much indeed, Art, and thank you, John, for having me here, and thank you indeed, honored guests, ladies and gentlemen, for coming out to this cold day to hear about cold fusion and other developments on the frontiers of science, chemistry, and physics, and perhaps other areas. Since we have a rather small group, I would say this is an opportunity to have a very informal presentation. I have a lot of material. Actually, it's almost impossible to cover the subject thoroughly in so brief a time as 3 hours. There's a lot to talk about. We'll get into it right away. But I would ask you, if you want to keep up with this field after you've done your own research, your own due diligence in determining that I know whereof I speak and I'm telling the truth and I'm giving you truthful facts and that there is an enormous field here to explore and get active in. The way to stay in touch with this is to perhaps subscribe for this very nominal price of $29.95. This is a labor of love. We do not get salaries for this. We who work on this, we will someday, we hope, when we are no longer printing 3,000 copies, but we're printing hundreds of thousands. And you'll be hearing a lot about the story that's on the cover of our second issue. We have 4 issues out now. We have issue number 4 here available. This is the famous clean energy technology Patterson process that has the first United States patent and is now entering commercialization even as we speak. We'll be talking about the recent demonstration that was conducted in Anaheim, California. All right, and the other thing, of course, for background is to read Fire from Ice, which is the cold fusion story up to 1991. Let me just tell you the outline of the day here. Just have a brief introduction, little brief history, just lead on into the classes of evidence that we have. Then let's get involved in talking about this demonstration that occurred both at a hot fusion meeting recently in Illinois and at PowerGen 95 in California, which is the largest fossil fuel and nuclear power generation conference in the Americas. Okay, a very dramatic breakthrough, and I will tell you the bottom line on this device that was demonstrated there in a number of forms. Over a kilowatt of thermal output power was demonstrated. In one case, they did it for 5 hours. That doesn't mean that it wouldn't go on indefinitely. They just did it for 5 hours. They were showing it to various industrialists. But the input power to that cell was only 1.4 watts. The output power was about 1.34 kilowatts. Very hard to miss a power ratio like that. And that's just the beginning, my friends. That is essentially an almost ready-to-go commercial product. All right. We can't avoid speaking about this regrettable affair, which is, I affectionately called Heavy Watergate, which is the scandal of attack, disinformation, etc., outright scientific misconduct on the part of certain universities against cold fusion. We'll proceed on to something else, which is what I would call the new energy part. There are other apparent energy sources in matter and in machines. I say apparent. I haven't signed on to all of these. This I have. There are certain cavitation devices in water, such as the Hydrodynamics Incorporated hydrosonic pump of Rome, Georgia, that appears to be absolutely validated at this point as a multi-kilowatt excess energy producer. Not with a high power ratio, but let's talk about that later. And then this unbelievable new direction of motors, magnetic motors that appear to produce more energy out than in, which is a absolutely shocking and heretical claim of the highest order, to say the least. The only problem is that certain major Japanese corporations are deeply involved with that right now. One of them has gotten the United States patent issued on it already, and there are more to come. And I personally feel that that field is real, but I am open. I am open to finding out why it is not real, just as I was open to finding out why cold fusion was not real during the first year. And then for dessert, after 4 o'clock, we can watch this 50-minute film, which was done by the Canadian Broadcasting Corporation and the British Broadcasting Corporation, broadcast all over Europe, all over Canada, but in effect banned in the United States. 50 television networks and stations were given Federal Express this wonderful film, and none of them chose to broadcast it to this day. The opportunity is there. They can immediately broadcast it if they wish. It shows cold fusion up to 1994, but they have chosen not to broadcast it. All right, and on we go. Well, what are we talking about here? We are talking about two oceans of energy, possibly. Water, which is around the planet, effectively infinitely available, especially since the amount of hydrogen required to run many of these devices may be either nearly nil or literally nil. And the ocean of space, which is vacuum, which may yet contain the source of energy. There are certain people, such as Dr. Hal Puthoff at the Earth Tech International, who believes that zero-point fluctuations in space-time are responsible for this energy capture, and that cold fusion experiments are merely the transducer of this vacuum energy. That remains to be seen. I wouldn't be here had it not been for where I was at the time of the cold fusion announcement on March 23rd, 1989. I wrote this book on cold fusion, Fire from Ice, and it's the source of why I'm here at all. I saw the story come out. I watched it with great fascination and shock, and I think I have some good background on the multi-dimensional aspects of this story. There are other issues. This was used from a previous discussion. There's no evening session. I have to get back to New Hampshire. But there are issues that I'll blend throughout this entire presentation. Government policy, congressional executive action, research funding at national labs. These are major issues that should be on the table right now. I urge any of you who have any contact with your political leaders to do whatever you can do as citizens to make them aware of it. At the very least, write your congressman a letter. Point out the issues, buy him a subscription, whatever. National security issues, military issues, obviously economic issues, which are part of our national security. These are the highest, this subject, in my own opinion, is right now the hottest and most important national security issue. It is not Bosnia, it is not anything else, it is this. Because this is going to free us completely from, in my opinion, oil from abroad. It will eliminate air pollution, it will do many other things. It will be a vast economic impact starting almost immediately. Geopolitical consequences are obviously involved here. The environmental impact is astonishing. There are social issues, taxation issues. What you find out when you study this whole episode of cold fusion and the related heresies to it, you find out that you learn a lot about the process of science. You learn a lot about the media coverage of scientific controversies, or lack thereof, lack of coverage, and research ethics, and the reporting of scientific results, and the general decorum of science, which turns out to be not very good at all when something is different. The scientific establishment does not like things that don't fit into its picture. At best, they usually give tongue-in-cheek little jokes about such things as cold fusion, crop circles, UFOs. But I think they've met their match with cold fusion, because cold fusion is something that can be completely reproduced. It will be commercially implemented, and as a result of that, the scientific establishment is in for the greatest shock to its foundation, possibly in history. We'll see. Galileo was a pretty good example, but they didn't have TV coverage then. Now we're going to dig up the TV tapes and the words and the printed words and the outrageous behavior of the scientific establishment over the last 7 years. We'll put it all together, and the people of the United States and the world can see what happened. Well, it's real after all. Nature, Science, MIT Plasma Fusion Center, Princeton Plasma Physics Lab, American Physical Society, Caltech, Harwell, England, Department of Energy, etc., etc. They were all wrong. About what? Cold fusion is an unknown phenomenon, or phenomena. Still is. We don't know what causes it. It's just a catch-all name. It was thought to be a nuclear process. Some people still think it is. Gives rise to excess power and nuclear effects, not always nuclear effects, in metals in contact with liquid and gas media that contain hydrogen and its isotopes. It's a generic catch-all term. When I say cold fusion, I don't mean literally fusion. There is substantial excess power that has been confirmed in these experiments, such as when you put 1.4 watts in and you get out over a kilowatt. And when you add up that energy, the magnitude is far beyond chemical explanation. Not only is it far beyond chemical explanation, my friends, but if it were chemical, in the classical sense chemical, you would expect to find ash there of a fairly substantial order when you're getting kilowatts of excess power out of a small volume of material. That ash does not exist, as far as we know. Certain theories which involve shrinking hydrogen atoms, yes, those may explain it. May. Not necessarily, may. However, as far as conventional mistakes, such as gross chemistry that is there that could explain this, no way. There is no known energy storage mechanism that could store energy like this. If there were, it'd be wonderful. But it doesn't exist, as far as we know. Nuclear products are confirmed, such as tritium, neutrons, charged particles, helium-4, and heavy element transmutations. One set of such transmutations in a Pons-Fleischmann cell has been confirmed by one of the worst skeptics in the field. He refused to print this data, so we printed it for him. Okay? We published his data. It was owned by the Electric Power Research Institute, which you pay taxes for. We published it. No commonly accepted physical explanation. I'm very interested in theory, by the way, but as far as my ability to deal with theoretical understanding of this, I can tell you why people say it shouldn't happen and why they say it should happen. But in general, this isn't as important as commercializing it and getting people to accept it. As I was telling you, there's overwhelming rejection by the scientific establishment, but nonetheless, there is an immense technological and scientific revolution in process right now. Home heating systems and home electric generation will be done. Years without refueling, if ever, and with only inexpensive materials. There will be cold fusion-powered steam electric automobiles. If there's an exhaust at all, possibly won't be an exhaust, just heat, exhaust, waste heat. I imagine, by the way, that the first cold fusion-powered car, you'll see if I'm right, a small one, a small vehicle, go-kart type, maybe a little bigger, will occur next year. I know the person who's trying to build one. We'll see a tape of him here today. Central station electric power generation is going to fade away, in my opinion. There will be zero, people will generate electricity in their homes. There will be zero CO2 emissions, and it will be extremely safe. As far as space propulsion, the easiest route to apply this to immediately, and I'm sure it will be done, is, I said fusion. What I mean is cold fusion, electric ion engines. Ion engines are ready to go for deep space flight to the planets and beyond. All you need is an electric power source. Nuclear fission doesn't fly, either politically or mass-wise or problem-wise, but cold fusion reactors in space, which I'm sure we'll see in the next few years, will power ion engines. High thrust-to-weight rockets, I have very little doubt these will occur also, so we may have launch off the Earth's surface with cold fusion engines. There are certain processes that I'm not even at liberty to talk about at this point that I have been witness to. I am not absolutely sure myself that they are over unity. We have to do more checking first, but they appear to be very high temperature. If they are correct, this is going to happen. Okay? Launch mass will go way down. Isotope production via metal lattice, neutron transfer, or whatever is happening to create these isotopes. We will have isotopes, radioactive and non-radioactive, in any quantities we want. Desalination and enhanced agriculture. For example, in a cold climate, you could have heated buildings to do agriculture. Why not have agriculture year-round in Siberia? Infinite possibilities, and of course, starships, particularly if the energy turns out to be 0 point, or some space energy of some kind. Two latest developments here, very, very nice for the field. The original Pons-Fleischmann patent has been granted, or should I say the announcement that they are going to grant it has occurred by the European Economic Community Patent Office. ENECO of Salt Lake City owns the worldwide rights. The other thing is Congressman Walker from Pennsylvania, who's in the district of Dr. Randall Mills, who's involved in the so-called hydrino theory of coal fusion and experiments and commercialization at Hydrocatalysis Power Corporation. He says in Popular Science, October 95, he says that one of the first bills to come out of my committee was the Hydrogen Fuel Act. Hydrogen seems to be a potential energy source with benign environmental properties. I'm also personally interested in the so-called coal fusion area. It's not fusion, obviously, but there's something that's producing additional heat, and it's been found in laboratory after laboratory. This man is the head of the Science Committee in the United States House of Representatives. Please write to him. No one at this point can explain it, he says. The hydrogen bill sets aside some monies to go into highly innovative research such as this. Nice. But of course there are those who don't believe, and here's one of them. This is what a coal fusion skeptic looks like. He's got a snarl, and he's very angry that this demonstration, this lecture is occurring today. I understand some flyers were put up in some of the physics departments here and there, and many of them were taken down. That's fine. I've had the same experience at MIT. It's universal. But we know what's going to happen to these folks. Here's a cartoon by Sidney Harris of the general problem in cold fusion. It is a problem. There's no doubt about it. This is a shocking, shocking paradigm shift. I'm on the verge of a major breakthrough, but I'm also at that point where chemistry leaves off and physics begins, so I'll have to stop the whole thing. Fortunately, Pons and Fleischmann didn't stop, nor the rest of us. This is a multidimensional story. It's astounding and revolutionary, many lessons. A too strange to be true human drama that proves that scientists are imperfect human beings. They are not objective automatons. They are people with emotions. And when you hit them in their emotional solar plexus with something that cuts at the very core of what they think their beliefs should be, they react in a very violent way. They are not objective by any stretch of the imagination. In fact, I wouldn't necessarily consider myself objective. I try to be. But I don't have much of a vested interest. A lot of us in this cold fusion field have suffered rather badly, okay? And so we didn't get $200,000 a year salaries, for example, for working on hot fusion. We have a belief that we were right about the evidence, and we pursued it. That's all we have, okay? Whether we ever get paid for it remains to be seen. I think we will. Revolutionary changes are on the way. Energy production, transportation, agriculture, the whole thing. I've gone through it already on that. Okay. There are many cold fusion processes, by the way. We're not just talking about the original Pons-Fleischmann. We're talking about, of course, the original one, which is very tough. Our two heroes took the toughest one. That's the system it started with. You know, heavy water, palladium, and platinum electrodes. Then there came the molten salt process of Liebert and Liao in Hawaii. You can look into that. High temperature process. Randall Mills with this unbelievable turning point in '91 that was announced. I understand we have a Randall Mills expert in the audience. Light water in potassium carbonate with nickel electrodes producing heat. Verified over and over again by numerous laboratories, especially Thermocore in Lancaster, Pennsylvania. Glow discharge in either light or heavy hydrogen gas. Piantelli in Italy is especially good in this now. In the latest issue of our magazine, we have the whole Piantelli patent here. I was in Siena, and I saw this apparatus. I believe that he's absolutely got it. They've worked on it for years. They're absolutely sure of the excess heat. It is stupendous. And Fiat, by the way, is behind his research. They are supporting his research. Ultrasonic activation by Equest Sciences Corporation. Ultrasonic melting of palladium underwater instantly or very quickly upon activation under heavy water. Ceramic proton conductors. Dr. Mizuno of Hokkaido University in Japan has this very hot process of solid electrolyte, it's called. Protons being conducted through solid materials of various rare earths and other materials that do indeed seem to produce, not seem, do produce tremendous excess heat. But also, he has seen isotope shifts now of a startling character. Magnetic, well, we talked about this, nickel and hydrogen, that's sort of like this. This was glow discharge. I shouldn't have stepped. Glow discharge. Jacques Dufour of Shell Research in France does this. Others do it. Piantelli is just hydrogen on nickel, triggered with magnetic stimulation, current pulses, and so forth. Turbulent activation, like the hydrosonic pump, where you just have turbulence in ordinary water. Intense turbulence and cavitation producing excess power. I wouldn't have believed it myself. It sounds crazy that a rotary device, turbulent, highly turbulent, within a shell, two steel shells, could produce more power in. But I physically was down there at their installation. I measured for my own sake to find out whether this was real. As far as I'm concerned, the number of BTUs we were getting into that 55-gallon barrel of 350 pounds of water, the steam condensed into it, was more energy already than the electric input. Not even taking into account the inefficiency of the electric motor and the other heat losses. It's, as far as I'm concerned, case closed that the hydrosonic pump is an over-unity cavitation device producing excess energy. It doesn't produce enough, unfortunately, to self-sustain, but who knows if it were developed, what would happen with it. Well, here's the context of the whole thing. The world population is increasing, either to 10 billion or 15, somewhere in there. We're here, struggling along. Fossil fuels are here. Sure, we could burn them, but they're obviously going bye-bye. Fission has got troubles. Sure, we could do a lot of things here. This is produced by a hot fusion man at Lawrence Livermore. Yes, hot fusion had the right idea. There is a problem in energy. We need something radically different. And they thought it was going to be hot fusion, which would give us reactors by the year 2050 to help this gap between the fossil fuels and the fission fuels. But now it's here. It's arrived. It arrived in 1989, and now it's here to be commercialized. This gap will not exist. We will have as much energy as we want. Infinite amount. There is no energy gap. End of the energy crisis. As soon as this is commercialized, of course. So we can have fun burning fossil fuels for, a couple more decades. No big deal. Maybe we'll bottle this stuff and put it on as, souvenirs of the bad age or the bad era or something. Anyway, the hot fusion people wanted to do it a different way. Very heroic effort. Unfortunately, going to be coming to an end. Is in the process of coming to end. I believe this is the TFTR at Princeton, the tokamak there, multi-$100 million program. Fusion had been getting about $340 million a year. This is the Nova laser system to bombard little pellets and create little mini hydrogen bomb stars. But they never could quite get their act together. Hot fusion is always the energy of the future and always will be, as they say. But now it is being truncated, even without cold fusion, by the Congress down to 240 million, and it will soon be abandoned completely. I have little doubt about that. Next year, I think, will be the last year that there's a tokamak program. Here's Pons and Fleischmann in their lab, just to show you the heroes who announced this amazing discovery on March 23rd, 89. They claimed this excess heat, they claimed neutrons, they claimed tritium. It turned out that their neutrons were improperly measured, no question about that. It turned out that They didn't really have good evidence for tritium. So what? It turned out that others have gotten tritium in spades in certain cold fusion experiments. This tritium should not exist. Radioactive form of hydrogen can't generate radioactivity from non-radioactivity, so we thought. But many people have done it now. And they've been greatly assailed. Dr. Pons, in fact, both of them are working for Toyota in France now at the IMRA Japan laboratory. And Dr. Pons has decided to give up his American citizenship because he feels very badly about what happened to him. And frankly, I don't blame him, but I wouldn't give up my citizenship. May 8th, 1989, it was all the rage. The media went wild over this story and then somehow disappeared, as they usually do when they lack interest in something. And they were told by the experts that this was nonsense anyway, so they decided not to cover it anymore for the most part. And so they went away, disappeared. It was on the cover of Newsweek. Maybe it'll come back again soon. Who knows? It was on the cover of Time. Okay. And it was on the cover of Business Week. All on May 8th, 1989. It deserves to come back, don't you think? This is what the little cell looked like. That's an actual cross-sectional view of what the cell was with the palladium cathode and the helical anode and various temperature probes. This was a Dewar flask. And the whole issue back then, it's all calorimetry. That's all it is. Is there more heat coming out or not? Is there more heat coming out or not? And yes, when the power levels were very low, it was a question. They might have made a mistake. The recombination of the oxygen and hydrogen might have explained it away. But not when you're dealing with, as we are today, with a kilowatt over 1 in. It doesn't, recombination is no issue. Besides, closed cells have been run. The recombination of the gases, of the electrolysis gases, is no issue at all any longer. This was the diagram that I put in Fire from Ice, just to show you the Dewar setup for calorimetry. It's just measuring the temperature difference between here and there and determining whether it makes sense. Given the power put in, you can do a calibration using a resistance heater. Calibrations were done. Calibrations have been done over and over again. By the way, the bottom line is the following. Here's a fundamental law of the cold fusion story. No scientific experiment will convince the critics. No scientific experiment will the goalposts keep moving. First they said they wanted closed cells. They gave them closed cells. They wanted controls, light water versus, they got that, okay? By the way, whenever you hear critics talking today, they'll say, oh yeah, it occurs in light water too, but they forget light water with nickel, not light water with palladium. You don't get substantial excess heat when you have light water with palladium, but you do get it with nickel. So the critics they're not thinking properly. They're quite frankly disorganized and virtually driven insane with their anger against this field. The goalposts keep moving. You give them better and better tritium results. They don't care. You give them better and better helium-4 results, and there are helium-4 results that are extremely good. They don't care. The only thing that will turn this around are commercial products and very high power levels. That's beginning to happen right now. The essence of the story was that it got to be called cold fusion because it was deuterium in a palladium lattice. And the question was, how does the paradigm of the hot fusion, which is shown here, fit into the cold fusion? Let's see. If you have a deuterium and a deuterium nuclei colliding and fusing in a hot fusion reaction at millions of degrees centigrade, Kelvin, you would normally expect 50% to be in the form of reaction products, helium-3, very rare isotope, and a neutron. 50% in radioactive tritium and a proton. So 50-50, a very small fraction in helium-4 plus a deadly gamma ray. Several tens of MeV, million electron volt. This would be, if real fusion were occurring, if standard classical hot fusion were occurring in significant amounts, certainly to the fraction watt level in a Pons-Fleischmann cell, Pons and Fleischmann should be dead. So, the opponent said, since Pons and Fleischmann are not dead, therefore their experiment must be wrong. There's a mistake someplace. arguing in a very rather absurd way that there could be nothing new in nature. It had to work like hot fusion in a plasma. Therefore, it's wrong. Okay, well, we know they're not dead. It's also called the dead graduate student problem. They are not dead. The graduate students are very much alive. This is what Princeton and MIT and others building the practical hot fusion reactors would like to do. They would like to take deuterium, which is in seawater, part of heavy water, and react it with tritium. They've done this already in reactor tests up there at Princeton, and create helium-4 plus a neutron. And this neutron that goes out very fast is the method that hot fusion would use to get heat. The hot neutron, the fast-moving neutron, would be captured in a molten lithium jacket of some sort, going through the steel wall, and that would be your wonderful heat. And in the year 2050, they might actually produce this monster. Professor Lawrence Litsky of MIT in nuclear engineering, who walked out of the Plasma Fusion Center in 1983 and wrote a major controversial front-page technology review story saying even if we could build these, and he thought we could, no one would want them. And that's true. We could conceivably build a hot fusion reactor in the future, but no one would want it. It would be commercially totally non-viable. Most people know that, but they still go on taking the money year after year. That's the way things work in the government, and ignoring cold fusion entirely. However, part of the cold fusion story ended up down this path. They said, okay, we'll give it to you that maybe something strange happens in the solid lattice, that maybe you don't get these two pathways, or you get some of this, you get some tritium sometime and little helium-3, but dominantly it might go into helium-4, and the gamma ray may get somehow absorbed as vibrations in the lattice somehow. But not too many people were able to see helium-4. A few did. It's never been particularly commensurate with the excess heat. That's the problem. Few people have seen it, but it doesn't seem to be commensurate. So, I think that it's completely open. We don't know what's going on. We just don't know. So if we don't know, let's just get the power up higher and higher, as it is now, to the point where some of these cells are so powerful, you run them continuously, and if there are nuclear products, if it is an unknown form of nuclear reaction, you should be able to see the products. If you don't see the products, well, sorry to say, folks, got to rewrite some physics at that point, or at least think about zero-point energy, because you can't throw away the experiments in favor of theory. You can't. You can try, but it doesn't work. You can't fool Mother Nature. Simple. During the cold fusion controversy, there was always this, because one half day after the Pons-Fleischmann announcement, ironically, the Exxon Valdez hit Bly Reef, dumping 10 million gallons of crude oil into Prince William Sound, and there we have our buzzard or condors, whatever they are, and sea lions waiting any more word on those fusion experiments. The animals were really interested in cold fusion because they were getting killed. Do you know the word cold fusion actually came up in 1956 on the front page of the New York Times? Because then muon catalyzed fusion, which I won't get into, that is that is the acceptable form of cold fusion, that muons, highly exotic particles, could catalyze fusion reactions. Teller was involved with this, Sakharov, other people. In any event, it was announced that it could be done, and it actually made the headlines in the New York Times. Ironically, the New York Times in 1989 waited a number of days before even reporting anything about cold fusion. Anything. And to this day, they have been terrible in their coverage. They haven't written a story on cold fusion since November of 1992. I have continued to send them the information. I will someday compile a list of all the information that I've sent them over the years, including the free subscription to the magazine, and it will be on record what they had in their hands and did not report. This is the problem. This is what it could be or not be. Could it be nothing? At one time, perhaps it could be nothing. In the first few months, maybe the fraction of a year, could be terrible mistakes, and the term pathological science, the science of things that never were. You know, like these other things that are useless to investigate, like UFOs and crop circles and psychic phenomena, all those things that have a huge database of very interesting data, but which the scientific establishment deems as pathological or sick, mainly because they don't like it. Nonetheless, cold fusion triumphed. The data is now overwhelming, but let's go through what I've had this slide for a long time now. It could be just low-level nuclear products and the heat was wrong, improperly measured. Steve Jones of BYU felt that way. Still does. No, actually, he rejects everything now. Heat only, he rejects everything, yes. Heat only, heat and nuclear separate, which I think is the ultimate silliness. Both exist, but they somehow have nothing to do with each other. And then there's some reason, I'm not saying that this I believe in. I fully believe this. This is incontrovertible at this point, in my opinion. It is a unified phenomenon. It doesn't mean that the heat is caused by the nuclear reactions. It means that whatever is causing this entire phenomenon or phenomena are part and parcel of the same thing. For example, suppose we're tapping into zero-point energy. If you can tap into zero-point energy and get energy out, you probably can wreck nuclei and create these nuclear products. Let's just give it that way. Or if it is a nuclear reaction, then obviously it's unified. One-to-one correspondence from the mass deficit to the energy coming out. Categories of explanation: that doesn't fly, that doesn't fly. These are totally the wrong magnitude. They're thousands to millions to perhaps infinitely off. If some of these cells can go indefinitely, Craven's had one go for 7 weeks. One of these CT cells for 7 weeks. Just turned it off. He got bored with it. In Italy, Piantelli had a cell running for 3 months, producing 20 watts excess. 20 watts excess for 3 months. Lots of megajoules. From a little rod, by the way, that was only 1 centimeter, I think, in diameter and about 4 inches long. Nuclear reactions with commensurate, possibly, commensurate excess power. Something else even more wonderful: nuclear products are auxiliary to the heat effect. I'm tending in this direction. Nuclear products auxiliary to the heat effect. But I'm fully open. I don't care. I'd love it to be that, because if that is true, then it's starflight time. We can run starships. And in fact, if there are starships visiting us, or if they have visited us, I'm sure in some way this type of energy might be involved. I feel strongly about that. I wrote the Starflight Handbook, by the way, in 1989, and while I was writing it, I knew that cold fusion was real, and I wanted to put that in, but the publisher wasn't too happy about that, so we didn't put it in. But the next edition will have maybe the whole book will be on cold fusion, new energy-powered starships. Well, we all know that they flew in December of 1903, December 17th. They were ignored for 5 years. The same thing is happening with cold fusion, and they even went to France to try to get commercialized because they wouldn't be heard in the U.S. We had another episode with affected the world a little bit. Goddard, the Germans picked up on his patent, made the V2s, then we had the space age. This was totally ignored. The New York Times said, of course, that this man didn't know basic physics. Rockets couldn't work in vacuum, but we all know that the New York Times was wrong. This is what the New York Times said about cold fusion in 1989. They said it was a horror show, the artificial heart, and cold fusion milestones in the history of entertainment, if not science. One wonders whether they will apologize. I hope they do. It's a good newspaper. I read it a lot. But I look in vain for cold fusion stories. This was the last cold fusion story. Actually, they had one recently on cold fusion. They called it cold fusion, but it was hot fusion. It was labeled cold fusion. It was dealing with sonoluminescence and the idea that maybe the temperatures in these little sonoluminescent bubbles, cavitation bubbles, this new phenomenon, that was a phenomenon that could deal to hot fusion, but done in the cold, so to speak. But it was really hot fusion. They mentioned nothing about cold fusion. They didn't even mention the fact that there was a corporation in the United States called Equest Sciences on the West Coast that does cold fusion using ultrasonic activation of palladium. Very strange. This was the last cold fusion story, November 17th, 92, after the 3rd International Conference on Cold Fusion. And we'll have our break shortly, but let me leave you with this is just the introductory part, myths against it. no credible evidence. That's gone now. If there is evidence, they don't need to explain where it comes from, even if it's tens to hundreds of megajoules, million joules per mole, which would be a very good hand grenade. It's kind of like having buying a AAA cell, you know, from Kmart and saying I got a 4,000-pound car that, with suitable gearing with my little electric motor, I can get that car going up to 100 miles an hour from that AAA cell. Stuff like that has come out of cold fusion cells. A megajoule is a lot of energy, and that's what we've been seeing in cold fusion. But I think physicists who thought that they knew about orders of magnitude don't seem to take them very seriously. They said there's no credible evidence for nuclear products of any kind, low or high. If there is evidence, it's not important. Oh yeah, all these arguments have been made. The negative DOE report was not a rush to judgment. It was very carefully considered, even though in all the books, you can read them. Read Taubes's book, Bad Science. Read Huizenga's book, you know, the head of the DOE panel. And all those books document what the people said on that panel that were biased from day one. It would be like having all O.J. Simpson's friends on the panel. Actually, they probably were on. They were on the panel, okay, on record, internally, that this was utter nonsense. They shouldn't even have a panel, Huizenga said, and they claimed that this was not a rush to judgment. While this report issued in November '89 was being foisted on the American people and the world, okay, to kill hope, literally. Kill hope and kill people. I regret to say it. People have been killed by default. They weren't killers. They didn't want to kill people. But by the delay of years and months that this technology gets implemented, X number of people have died from air pollution and other bad things just because it has not been taken care of. But it was a rush to judgment. All cold fusion experiments are non-reproducible. That is baloney. It was perhaps the case in the beginning, but certainly there were reproducible things that were emerging at that time, and there was a rush to judgment. Japan, they used to say that this doesn't exist. Now they say it exists, but it's stupid. All right. Goalposts move again. But nonetheless, conferences kept going. After I resigned from MIT for reasons we'll go into later, there was the Como conference, which I did not get to go to, in Italy, in Como, Italy. That was the second international conference. The first international one was in Salt Lake City. The third was in Japan, Nagoya. I was there under the auspices of none other than many of the Japanese top physics research societies, including hot fusion people. In Japan, for some reason, much more politeness, cooperation between hot fusion and cold fusion. They don't like each other, really, but now that the hot fusion people in Japan know that they're cooked, they'll probably just switch all over to cold fusion, because that's where the money is anyway. The fourth international conference was in Maui, Hawaii. I went to that. That was lovely. Maui was lovely. Wonderful conference. Electric Power Research Institute produced proceedings with papers this thick. That thick, friends. Papers. Okay? And the fifth international conference occurred in Monte Carlo, Monaco. I went to that. Lovely place, too. We know where to have our conferences. And we have to relax from the cold fusion war, after all. Okay. Popular Science in August of '93 did a wonderful story, very balanced, as appropriate. They've kind of disappeared. Jerry Bishop of the Wall Street Journal, who normally does these things, he did that. Normally does cold fusion. He's been hiding out on us. He did that. I was quoted in there. Huizenga was quoted in there. It's all on the record. Kind of an interesting story. And that led, by the way, publicity is very important. As the chief science writer at MIT, I can tell you it's important. Many scientists don't realize how important publicity is. Publicity helped kill cold fusion. You'll see that later, how they did it. How the MIT hot fusion people launched a publicity campaign that they'll never owe up to against cold fusion, okay? And then they have the audacity to say that the announcement of cold fusion at a press conference was a bad thing. You should see what they did. Wow. Okay, but the point is, we got people who saw this article who came out of the woodwork. They said, oh my God, the hydrosonic pump. We have something that's over unity. We've never understood why it is. Could you help us out? Maybe it's cold fusion. All right. So a lot of things that people are seeing that are obviously anomalous are now coming out of the woodwork. It's wonderful. So I'm all in favor of publicity. This was a wonderful article by Dr. Storms of Los Alamos. See, cold fusion coming out of the garbage can. Okay? They threw it in the trash can, but it's coming out. And this was in May, June 94. Wonderful article. I actually had an article that was ready to go in 91, and it had been approved. The physics department got to it. It was approved by the editor, former editor. They got to it, and Feshbach, world expert on nuclear energy, nuclear physics, he said to me, when I asked him why he objected to this article and killed it, helped to kill it, he said, I've had 50 years of experience in nuclear physics, and I know what's possible and what's impossible. And then I said, well, Dr. Feshbach, would you at least look at the latest evidence as reviewed by Dr. Storms, who then, years later wrote this, or Dr. Srinivasan from India? And he said, no, I will not look at any more evidence. It's all junk. Got very angry, hung up the phone. That was it. And that was Dr. Storm. We started a magazine. Unfortunately, it was with the wrong publisher. It was called Cold Fusion originally. This was our first issue out of Peterborough, New Hampshire. That's the wrong place. It no longer exists. The guy puts out a little newsletter, which isn't worth the paper it's written on. But this is our second issue. There is a third issue. I didn't bring along a slide of it. But it just shows that in the spring of 94, we were rolling. And we'll get on to the evidence real soon. We'll have our break. But let me end this phase of our meeting today here with three more slides, and then we'll have our break. Let's summarize all of what we've just now gone through. And again, do diligence, do your own research. I'm telling you what I believe. You look in and find the data yourself. I'm not telling you to believe this. I believe it fully, just like I believe airplanes are flying, okay? I can measure things. I know how to measure. But you do your own diligence. But here it is. Theory cannot be used to reject experimental evidence, no matter how strong the belief in the universal validity of past theory. You would think that every scientist on Earth would believe that, right? They don't. They don't believe it. They pay lip service to it, but they don't really believe it in the practical sense of, if you see something new, by God, take it seriously and see if there's a new theory. I thought science was all about that. New things, new theory, new phenomena. But if you keep with the old theory, how can you go anywhere? It's stupid. The process of science today is incremental change, and occasionally breakthroughs are allowed which are within the framework that they want. They don't want the breakthrough that's out of their framework. A paradigm problem. So we have the paradigm police. Extraordinary claims do not require extraordinary proof, just proof. That's it. Now what they want, the goalpost keeps getting moved. The latest position of the goalpost is, all right, you have a kilowatt reactor with 1 watt going in. Okay, we sort of believe that, but that doesn't rule out the chemical explanation. So therefore, you must provide us with the reaction before we will believe it's anything new. Complete abandonment of logic. This is the mother of all anomalies, in my opinion. What will happen after this great turnaround? Will it be business as usual? Will it be widespread rejection of the scientific establishment? Increased acceptance, a possibility that other anomalies might be real too? I believe so, and that's a very healthy thing. The scientific establishment does not want that to happen. They do not want to be shown as having defects in their methodology, so that UFOs and other things become reasonable things to study. I'm not saying UFOs are real. I'm very interested in them myself. Crop circles, psychic phenomena, such as being measured now at laboratories in Princeton and even in the Central Intelligence Agency. Okay? There may be a new metaphor in the language. Oh yeah, it was just like cold fusion. But instead, it won't be a bad thing, it'll be a good thing. It'll be like, yeah, they did a cold fusion on it. In other words, they got rid of it, and they shouldn't do that. Don't do a cold fusion on things. Now it's the other way around. Let me give you, then we'll go to, I'll stop right here after this question. We'll take a break, and then we'll come right back and do the evidence, overwhelming evidence, and see some videotapes and slides and things. would it take to make cold fusion disappear? Simple. The exceedingly improbable determination that systematic errors have been made by researchers in half a dozen or more measurement areas, tritium, heat, neutrons, charged particles, gamma rays, helium-4, transmutations, in each of which diverse experimental techniques have been applied. Now, before we had very powerful cells, that's what would have been required to get rid of cold fusion. And of course, I never thought for a minute that it would go away. Could have gone away. All the experiments could be wrong. Doubted it. Said I doubted it in 91. I was right, I think. Now we have to add another thing. I'll add it for the next lecture. You will have to get rid of all commercial devices that are producing multi-kilowatts of energy with either no input or minimal input. So once these commercial devices start coming out, I hope that the physics establishment is ready to get rid of them all, because that's what they're going to have to do as they come off the assembly line to make this disappear. It will be impossible. And so the energy source has been unleashed to the world. And let's come back after the break. We'll break right now and enjoy some coffee. Let's come back in 10 minutes, okay? Come back at 2:15, okay? This is part 2, cold fusion part 2. And we're going to see a little videotape in just a few minutes. May see two, actually. There was a very large meeting in Anaheim, California, December 5th to December 7th. Very historic time, I feel. This was a major industrial trade show in Anaheim at the Anaheim Convention Center. And so we have Texaco and all other, fossil fuel companies, nuclear companies there. But a very unusual exhibit, the most important one in the entire place. This substitutes, by the way, for the video. I don't have videotape of that cell at the conference. Don't worry, we have, this is as good if not better, because you really can't see anything from a videotape. We'll eventually have a videotape. I will show you their commercial videotape, which is very good, of their general process, so that those of you, the cognoscenti here, chemical engineering people and physicists, might get some more insight. Feel the heat. What a wonderful poster. You can feel it. It's not, it's not an experiment anymore. You come up to it, it's hot. It's like a hairdryer. And there was their cell. I wish I could have been there last week. I have teaching responsibilities, so I couldn't be there. But next time. And that was their booth. They have a very nice logo. Okay, Clean Energy Technologies. By the way, this is Dr. Patterson, the inventor, and his grandson, who's the CEO of Clean Energy Technologies. Nice young blood, ready to go to help end the fossil fuel age. One company at least. This is their ad in our magazine, Clean Energy Technologies, the hand with the sun, and showing the essence of their technology, which is beads. Plastic beads with a copper flashing and a nickel layer, palladium. I was asked, here are some of the U.S. patents that cover it. There was one issued in 93 that talks about the process. It doesn't talk about cold fusion, but it's obviously referring to an energy-producing source. We'll do the little videotape now, and then we'll get into, this is the shockaroo, this is the cell. There it is. You'll see later how this works. The heating is done right in there, in a 40 milliliter volume with beads, aquarium pump here, heat exchanger, and a fan blowing the 1,000 watts of heat out. And the calorimetry is very simple. It's just temperature in and temperature out, delta T and flow rate. Power input is measured with standard techniques. We'll get into that. Let's do the videotape first of two things. I think let's do their industrial videotape first. The Clean Energy Technology videotape. It will go on both of these monitors. And let's give them this is their point of view. This was before this conference, but it's a wonderful tape. And then I think we'll do Dr. Craven's a bit. I think that would be fair to him. And we'll play it.
In 1989, Drs. Pons and Fleischmann, two scientists in Utah, shocked the world with their announcement that fusion reactions could be achieved at low temperatures. Since then, hundreds of scientific organizations around the globe have quietly continued their quest to harness this potentially unlimited energy source.
The sun's fusion reaction is the ultimate source of all life-sustaining energy on Earth. Even the energy contained in the fossil fuels we use today is the energy of the sun captured by plants and animals millions of years ago and then released when we burn these fuels in our power plants and vehicles. These energy sources are inefficient, expensive, and most important, limited and non-renewable. Science has been looking for a solution to this energy problem for years. Clean Energy Technologies Incorporated has the solution today. Clean Energy Technologies, or SETI, based in Texas, is a private corporation formed to be the exclusive licensing agent for the technology developed by Dr. James Patterson. Dr. Patterson has invented an energy system that will solve the problems of dwindling energy reserves and satisfy the growing energy demands of today's economies without destroying the environment. It will entirely change the current methods of energy production and utilization. A safe, reliable, and efficient way to harness the energy of the sun using the most abundant resource we have on Earth, water. Dr. Patterson has discovered that the excess heat generated by the interaction of water, palladium, and platinum can be efficiently captured and harnessed. This discovery is so profound that conventional science is now trying to understand its theoretical and practical implications. The technology is covered by SETI's 4 patents. These are the first patents of this kind to be issued anywhere in the world. This new hydrogen energy is more commonly known as cold fusion. Clean Energy Technologies is proud and excited to present the fascinating story of the Patterson Power Cell and the reality of a clean, abundant, efficient, economical 21st century power source that is under development today. A source not based upon the burning of fossil fuels nor the splitting of atoms. Hydrogen that is found in every molecule of water is used to stimulate an excess heat reaction that generates a tremendous amount of energy. That heat, then, is transformed directly into other forms of energy. At the same time, hydrogen and oxygen gas is created as a byproduct. SETI was formed with the prime objective of making this exciting new discovery a commercially viable energy alternative. Dr. Patterson originally developed much of this new technology in the early 60s and 70s while working on the amino acid analyzer, which is the foundation of all of today's DNA analysis. He is now SETI's chief scientist.